So, I'm sure I don't need to explain that despite its benefits, mining creates significant disturbances. Post-mining landscapes have changed soil profiles, properties, landforms, vegetation, and response to rainfall. Post-mining rehabilitation aims, amongst many other goals, to reinstate a safe, stable, and non-polluting landscape. However, gully erosion, which is where erosion causes a channel to be incised into the landscape, as you can see on the right, impacts the ability of rehabilitation to achieve these goals. Soil is displaced, seeds and seedlings are buried, and there's potential for contamination outside of the original mining area. In my research, I tried to predict what landscape features may result in gully formation occurring. So, I tried to predict where will gullies form on landscapes, specifically in mine pit rehabilitation. As gully erosion is a complex process controlled by many levers, which in broad categories relate to soil and water properties, I look at how landscape features in terms of how they change where the water flows to, how much water flows to a point, and how the soil saturation is affected. So what is the landscape doing to where the water goes in a runoff scenario? Why? Because large-scale management of landscape features may be a lever that's more easily adjusted to create more resilient landforms. So in my case study area, a contour ripping surface is applied to the pit's final landform to control and store surface water movement, which you can see on the image in the top here. It's like terracing, it's just on a smaller scale. I use ultra-high resolution surface models of the rehabilitation that show the height of the soil surface in 5 centimetre pixels. And using this imagery, I have been able to determine how the channels applied in the contour ripping process actually change the surface water movement. And you can see that in the image below here. You can see some areas where the channels are actually along the contour line instead of downslope. So I found that although ripping creates a longer, less direct flow path downslope in rehabilitation, it also increases accumulation upslope, which may be more negative for erosion formation. I've also applied a range of methods to predict erosion at any point within the rehab. Some have worked, some haven't. It's not a perfect science. And I'm now looking at how the overall landform shape affects soil water saturation, which can lead to more erosion formation. So ultimately, I want to provide guidelines for the construction of post-mining landscapes that are resilient to gully formation.